So what we are going to look at today is using these BCA charts, before, change, after charts, in order to solve limiting reactant stoichiometry problems. And this technique is especially useful if the question is asking how much of a reactant is left over. Although it can be very intimidating with all of these boxes. So that's why this is an optional way to do these problems and an optional way to learn it. So the question is asking us how many grams of sodium fluoride, NaF, can be made from 100 grams of sodium and 100 grams of fluorine, and then how many grams of the excess reactant are left over. So before this reaction starts at all, I start with 100.0 grams of sodium. I start with 100.0 grams of fluorine, and I have no product, no sodium fluoride. Because I know that how these compounds relate to each other is through their coefficients, through the number of moles, I need to convert these two starting amounts over to moles. And so I'm going to show you the work in the boxes down below. Right, so in order to fill in box number 1, I would take 100.0 grams of sodium, and I would just convert that over to moles using the molar mass from the periodic table. The number that I get there is 4.349 moles. So this is this is 4.349 moles of sodium. And I'm just going to do the same thing with the 100.0 grams of fluorine. Right, convert that over. And that is 2.63157. And of course, if I have no grams of sodium fluoride, I have no moles of sodium fluoride. And now I calculate the change. And so one of these two amounts is going to get all used up. And I cannot assume that it's always going to be the smallest amount, because my coefficients tell me I'm going to use up twice as much sodium as fluorine. So even though I have less fluorine, that may not be the limiting reactant. So what do? I always assume that the first reactant is the limiting reactant. So that guy would go down by 4.349 moles, right? The limiting reactant would get all used up. But now I would need to figure out box number 4. How many moles of fluorine would also be used? And how I do that is I say, okay, well, if I used 4.3497 moles of sodium, according to the coefficients from the balanced chemical equation, which say I would use 2 moles of sodium for each 1 mole of fluorine, that if I used up all my sodium, I would use at the same time 2.17 moles of fluorine gas. So I would use up, so that's another subtraction, 2.17485 moles of fluorine. Now, when I look at this, I notice that if I were to actually do this subtraction, what number would I come out with? 2.6 minus 2.1 is still a positive number. This would actually come out to be, like doing the actual math, 0.4567 moles of fluorine left over. So that tells me that fluorine is not my limiting reactant, that it gets, some of it gets used up, but not all of it gets used up. Remember, if I'm assuming that sodium is my limiting reactant, and so I'm subtracting all of it, then how much is left over afterwards is none. That would be 0 moles and 0 grams. Right, so how did I get this box number 7, right? I subtracted box number 4 from 2. And so since it's positive, I know that the sodium was my limiting reactant. how am I going to get box number 9? I am going to, use the limiting reactant, box 3. So the limiting reactant, once I decide which one is the limiting reactant, that amount is going to control how much product I will make. So if I use up 4.349 moles of sodium, according to the balanced chemical equation, I will make 2 moles of sodium fluoride for every 2 moles of sodium that I use. So that means that I will make 4.349 moles of sodium fluoride. So this is 4.3497 moles of sodium fluoride. And of course, if I started out with none and I added 4.3497, I'm going to wind up with 4.3497 moles of sodium fluoride. And then, of course, if I look back at what is this problem asking me to find, it doesn't ask me to find the number of moles. It always asks me to find the number of grams. So I need to find this number right here. So how do I do that? I simply take the number of moles, 0.4567 moles of fluorine and convert it back to grams. And that number is 17.355 grams. Okay. If I am looking back at significant figures with all of this, let's see. Oh, these actually only have 3 significant figures. So I should just have my answer in 3 significant figures. So that would be 17.4 grams of fluorine left over. And how many grams of sodium fluoride will I make? So I take that 4.3497 moles of sodium fluoride and I convert to grams. And that equals 182.6 grams. Now when I should put NaF here. Now, this is where you can really do a good job of checking your work, because however many grams that you start with, you should wind up with the same amount of grams after. That's the law of conservation of matter. And so if I look, what did I start with? I started with 100 grams of sodium and 100 grams of fluorine. So total amount that I started with was exactly 200 grams. At the end, I had 17.4 grams of fluorine left over, and I had 182.6 grams of sodium fluoride that I made. So afterwards, I have exactly the same. I have 200 grams of material at the end. And so that proves that I've done it correctly, because the law of conservation of matter still holds up.